Hi, welcome to iClone and Substance tutorial. In this tutorial, I'll be showing you how to publish a procedural material from Substance Designer and getting that to work in iClone. So in this scene, we have a substance material called layer decal. For those of you who don't know what a decal is, simply put, they are stickers, and as such, you can layer them on top of each other and you can position them however you like. Now, back in iClone, this layer decal has a base maps layer, which creates this bricks texture here, with a diffuse, normal, and specular. We can also adjust the density of the texture here using the slider. And the decal layers also have a diffuse, normal, specular, but it has an extra mask. The mask is used to cut out the texture from the background. For white areas, it is opaque, and for black areas, it is transparent. Like I mentioned before, decals are like stickers. So we can control them by positioning them horizontally, vertically, rotating them from 0 to 360, counterclockwise or clockwise, and finally we can scale them horizontally and vertically. We can also control aspects of their look. For example, this decal 2 door texture, I can make this door completely disappear, leaving behind the normal contribution. So it kind of looks like the shape is carved into the wall. I can also use its own specular or the background specular, like so, or I could increase the specular strength and the diffuse strength, but completely decrease the normal strength, creating a painted on effect, like so. So with 4 decal layers and 1 base layer, there are many possibilities with this substance material. In the next section, I'll show you how we put together this material in Substance Designer. So here I have the layer decal material open in Substance Designer. Let's quickly walk through the parts of this graph. On the left, we have the input textures for the graph, and you can see by the blue frames the type of input textures correspond with what we see in iClone. So here we have the base. So here I have the layer decal material open in Substance Designer. Let's quickly walk through the parts of this graph. On the left, we have the input textures for the graph, and you can see by the blue frames the type of input textures correspond with what we see in iClone. So here we have the base, decal 1, decal 2, all the way to decal 4. And those are our input textures. Now if we zoom out, you'll see that there are these nodes over here that are colored in red. These are called subgraphs. And a subgraph is simply a graph inside a graph. This material uses 4 custom subgraphs. The first one we'll introduce to you is base color. The base color is responsible for giving a default color for each texture channel. The density node controls tiling, and down here we have the alpha or mask node, and this allows us to create a mask out of a transparent diffuse channel here, or we can override it by using our own custom diffuse over here. The next one is the X-form node. X-form here is short for transform, and this is simply a way for us to position, rotate, and scale our decals. Next, we have the material blend, which is provided in Substance Designer and therefore not something that we custom make. Now we simply use this to blend our base layer and decal layers together. And if I double click on it, you'll notice that it has opacity controls for diffuse, normal, specular. And we use these opacity controls for diffuse, normal, and specular strength contribution. Now all of these import textures are piped through these subgraphs to give us the final output textures, which we have the diffuse, normal, and specular. In the next part, I'll dissect the custom subgraph in this material and walk you through their creation. This is the base color subgraph, and it simply takes the input textures and puts it on a color background. Then the result is piped into the output. So for example, if this 6 was a diffuse input texture, it would be piped into this blend here, and it simply puts it on this gray background. Then outputs that as a diffuse output. This subgraph is useful if, let's say, you're missing a normal texture, but you don't want the shader to look weird because it's missing a base normal color, such as this light blue. This gives us an extra layer of shader control. Now I'm going to show you how to make this graph step by step. So let's start by creating a new substance, and we'll call this the base color. And the size mode, we'll change it to relative to parent. In outputs, add a mask. Press OK, and it creates the outputs that we need. Let's go ahead and create the inputs. So let's add a node, color image input. And on the right here, let's see, having a bit of a difficulty seeing that. We're going to add a usage. This will be our diffuse. And go ahead and call it diffuse. And this will be our input group here. Okay. So copy and paste, Control V. Double click on this. And this will be our normal. We'll change this to normal. It's also the group input. Copy paste. And this is our specular. Specular. There he is. Now the last one is the mask, and what we want to do is add a grayscale image input, because a mask is just black and white, it's monochromatic. So I'm going to add, and I'm going to find that mask here. It's also the input group, and I'm going to call this mask. So now we have the 4 inputs. Let's create 4 base colors. Create a uniform color. And I think I'm gonna go with like a light gray. So I'm gonna pick a very light gray here. That should do it. This is gonna be our diffuse background color. I'm going to add another one, uniform color. And I'm going to pick a default normal color. So to do that, where the max value here is 255. So default normal would be 128 in red, 128 in green, and maxed out blue. And this is 128, 128, 255 is our default normal color. Okay. So now that gives us that nice light blue. For the specular, I'll just go ahead and copy and paste the uniform diffuse color and change this to black. Because by default I don't want any specular. I'm going to copy and paste this, and this will be our default mask color. Change this to grayscale and pick a light, like a white for our default mask. White meaning it's completely opaque. Now we create the blend. So we want just a normal blend, and that's disconnect. We should disconnect this one. Okay. Type in the diffuse into the blend, input 1, and the uniform color into input 2. Then take this and pipe it into the diffuse. So it's really just that simple. Anytime we have a diffuse input, it's going to override, or it's going to overlay on top of this uniform color here. Now take this, copy paste, let's go ahead and copy paste this 3 more times. Then we do the same exact thing. For some reason it's not connecting from here to here, so I'll just do it the other way. There we go. Okay, so last step, compute no thumbnails to check if everything is okay. It looks correct. So that's it for the base color subgraph. Let's move on to the density subgraph. This is the density subgraph, and it helps us to tile textures. This is useful for keeping texture scale consistent with the object it's applied on. So for big objects, you would want a higher density, and for tiny objects, you will want less density. Don't confuse density with resolution. They are independent aspects of a texture. No matter how dense a texture is, it's not going to change its resolution. So in this graph, I simply have 4 texture channels, and these are inputted into a series of transform 2D nodes. For the transform 2D, we have a transform matrix with a function input. So if I click on this, you'll see that we have a custom function here. I'll show you how to make this custom function step by step. Now back into our density graph. It works like so. If I input a texture into the transform 2D, its output is exactly the same. However, if I double click on a blank space and I change this density to a higher value, in this instance, it simply tiles it to become more dense. Let's say if I double click and I change the value to less than 1, then you'll notice that it actually scales the texture. All of this is then connected to the output. So let's get started. So now we're back in our previous base color subgraph, and let's go ahead and save this package out. We can right click on it and save as. And I'm going to call this LD underscore subgraphs, because we're going to make other subgraphs. Go ahead and save that out. Now we'll create a density graph by right clicking new graph. Give it a density name. Size mode, change to also to relative to parent. And same as before, we're going to add a mask. Hit OK. And you'll notice that in my Explorer, I have a new graph. Same as before, I'll need the 4 input channels. So I can simply double click on my base color, select the 4 channels, copy this, and go back to my density and paste. Now I just need a series of transform 2D nodes. add node, transform 2D. And I'll go ahead and dock my info panel to the right hand side. The transform 2D has a parameter called transform matrix, and we can create an empty function by clicking on this arrow here. Empty function, and then we can open up this function by clicking on this icon again. And inside this empty function, we're going to add a constant float, 0, and we're going to add an element under variables get float. Then we're going to create an output of vector float 4. Because the transform matrix has 4 floating point values. Let's go ahead and disconnect this for now. And we're going to add another element called vector float 2. I'm going to copy and paste this again. So we have 2 vector float 2 and a vector float 4. And what we're going to do is we're going to connect this to the top and the bottom. Then with the 0 here, we're going to connect it to bottom of vector float 2 here on the top, and the top vector float 2 here on the bottom. Then we're going to get this get float here and connect it to the top here, and then the bottom of this node here. And finally, we right click on this vector float 4 to set as output node. Right now this function doesn't really do anything because we have a get float that is not grabbing any kind of value. So what we have to do is go back to the density, double click on the blank space, and add an input parameter. We're going to give it an identifier called density and a label also density. I like to set the maximum of my density to 10. So now we have our input parameter, and then we can go back to our function, and then the get float, I can set it to density. And because density has a default value of 1, the default value of this transform matrix is 1, 0, 0, 1. Now back into our density, we have a transform 2D set up, so we could simply copy and paste this 3 more times. Then simply connect input to the transform 2D and then the transform 2D to the output. Like so. Now let's move on to our alpha or mask subgraph. Our alpha or masked subgraph can convert an alpha channel of an input texture to a grayscale mask. It also has the added functionality of inputting a custom mask texture. Here's my diffuse input, and here's my custom mask input. If I use the 6 with an alpha channel, and if I connect it to my channel shuffle, you'll notice that it creates a black and white mask. I can also override this mask by simply creating my own and putting it into the blend. So let's go through the steps to create this subgraph. So we're back in our layer decal subgraphs, and let's go ahead and save this. And now we're going to create a new graph. This time we'll call it alpha or mask. Again, we're going to set the size mode to relative to parent, but this time we don't need the outputs. So go ahead and take them out. We only need one output, and that can be a base color. Hit OK. Now we need 2 inputs, one for the mask and the other one for the diffuse. So let's create a color image input, and let me get this back here. I'm going to label this as input 1. I'm going to copy and paste that. And this is going to be input 2. Then I'm going to create a uniform color. And we're going to make this white. grayscale all the way to white. Then I'm going to add a channel shuffle. Then input 2 will be our diffuse map, so we're going to put it into A, and then our uniform color into B. Double click the channel shuffle and go to its parameters. You'll see that the default is set to the input 1 channel. What we want to do is take this alpha channel and turn it to input 2 alpha channel, which is black. And then we're going to turn the red channel into alpha 1 alpha channel. Also the green channel the same, and the blue channel is also the same, alpha 1. Then we're going to need a blend, so add a blend here and connect our input 1 into the blend, which will override. If we do have a custom mask, it will override our channel shuffle result here. Then we're going to turn this result to a grayscale map. So simply create a grayscale conversion here, connect that in here, and then connect that into the output. If I press D on this grayscale conversion, it will simply dock it. This graph is really just that simple. Next, we're going to create our X-form subgraph. So back in our LD subgraphs, let's go ahead and save this out and create a new graph. And we'll call this the X-form graph. Size mode is also relative to parent. Add a mask. Press OK. Like what we did before, let's go ahead and copy the input channels. And paste them in here. Now we're going to create 3 transform 2D nodes. So add a node, copy, paste, paste again, and we're going to work on the function of the first node. So go to the transform matrix and change this to an empty function. Then click on this icon, and this is going to be our scale. So let's create a get float, or rather, we need a get float 2, because we can scale this in horizontal or vertical. Then add a multiplication, which is under operator. Then we need a float 2. With this float 2, I'm going to put in 100 for the X and 100 for the Y. Then we're going to pipe that into the second multiplication channel. And I'm going to find a very helpful node in the library called scale matrix. I'm going to go ahead and drag this in. And what this does is it simplifies the scaling of the matrix for me. Now let's go ahead and connect this multiplication into the scale matrix, and right click on the scale matrix and set as output node. So we need to grab a value in our get float 2. In order to do that, go back to your X form and double click on empty space. Then under input parameters, click on the plus button and select type editor float 2. And we're going to add the ability of scaling this texture in the negative. I'm going to give the min -10, and I'm going to give the max 10. Then we're going to give this parameter a group called Xform and the label of scale. So back into my function, I'm able to grab the input 4 parameter. Now this is not a really good name for our input, so I'm going to go back to my Xform and double click again in the blank space and actually give it a reasonable name. So I'm just going to call it scale. When we go back to our function, it'll automatically update to the name change. So what's happening here is I'm getting a float value from -10 to +10, and I'm multiplying that by 100 and feeding that value into the scale matrix. Now back to my X form. Now we're going to work on the rotation part of the transform. And this part is a little bit more complicated, so please bear with me. First select the transform to the next in line. Then go to its parameters. And under this transform matrix, go ahead and create an empty function. Then we'll click on this icon again to enter the empty function. Then in the library, we have a very handy node provided for us called the rotation matrix. Simply drag that in. And what this node does is take a floating point value from 0 to 1 and rotate the matrix from 0 to 60. I'm going to go ahead and set that as my output node for now. Since this node takes a value from 0 to 1, it's not very intuitive to use. So what we'll need to do is convert 0 to 360 into 0 to 1. So we're going to need to do some math here. So let's start out by adding an element under variables, get integer. So this is going to be our 0 to 360. Then we need to convert that by adding an element cast to float to a floating point value. Now to get from 360 to 1, we're going to have to divide it by 360. So let's add another floating point value. This time it's a constant. And here we're going to put in 360. Then we're going to do another element. This time it's an operator and it's a division. Okay, so we're going to grab this number here, which is our 0 to 360, convert it to a float and pipe it into input 1. Then we're going to take this 360 float and pipe it into input 2. Now if I connect this division into my rotate matrix, it will work as long as I feed a value here from 0 to 360. However, I want the option of rotating in a negative, and in that case I'll add a counterclockwise or clockwise true or false statement, and that will simply multiply this value I get here 0 to 360 by -1. So let's do just that. First, disconnect this. Drag this out further here so we have a little bit more room. Add a float constant, and this will be our -1. Then to go counterclockwise, we need to multiply by -1. So I'm going to add an operator, multiplication. Then taking this, pipe into input 2, and take the division and pipe into input 1. So what we have here is I have a positive value coming from this division, and I can connect it to my rotate matrix or anything I want. Or I have a negative value, and I can also use this to input into whatever I want. But what I want to do is add a control so I can pick whether to go counterclockwise or clockwise. So let's add a get boolean. And it's under variables, get boolean. And then we're going to add a element which is under control called if or else. Now a get boolean is like a true or false. If or else basically means if it's true, then take input 1. If it's false, then take input 2. And whichever one it takes, it'll go ahead and output the result. So I want to do a positive value on the top and a negative value on the bottom. Then I'll connect this into my rotate matrix. So now let's add the control into this function. Go back to the XForm graph and double click on a blank space. Then under input parameters, press the plus button and change the type editor to integer 1. Let's call this rotate. Label is the same, and the group is also XForm. The default value we'll set to 0. The min we'll leave as 0, and the max we'll set it to 360. Let's go ahead and clamp this as well. Now let's add another one, and this time we're going to call this clockwise. Then under type editor, I'm going to select Boolean, and I'm going to set the default to true. The label is also clockwise, and the group is xform. Now back to our function. Our get integer is the rotate, and our get Boolean is clockwise. So let's double check this graph again to make sure everything's okay. I have a get integer of 0 to 360, converts to a float, and it is divided by 360. So that is correct. Now I have a get Boolean of whether or not this is rotating clockwise or counterclockwise, and if it is true, then it passes the result of this division through to the rotation matrix. If however this is false, I multiply my division result by a -1. Then this is passed through to the rotation matrix. Let's go back to the xform node for the next transform 2D node. So once again, I go into its parameters, and I create an empty function under offset. Then click on this icon to start editing. This function is simplest by far because all we need is a get float2. So variables, get float2. Then set this as an output node. Let's go back to our xform, and again double click on a blank space. Let's go ahead and add a translate, and we'll call this simply translate. Label is also translate, and the group is also xform. The type editor, we use float2, and I'm going to change the default to 0 and 0. The minimum I'll change to -1, and we'll go ahead and clamp that as well. I like to change the label of x to h for horizontal and y to v for vertical. Now that this translate is set up, I can go back to my function and double click on this get float2 and set it to the variable that we just created, translate. And we're done with the translate function. So go back to xform, and we'll start to connect all these together. Because I have the scale, the rotate, and the translate function set up correctly, I can go ahead and select all three, copy and paste 3 more times down in a column. Then what we'll do is add some very handy frames. So go ahead and select the column, right click, and add a frame. Here in the comments, I'm going to call this scale. I'm going to do the same for the second row. Except this time, I'm going to call this rotate. And then the third row, I call this translate. Then a little cleanup. We start to connect things together, like so. Just connect it all up, row by row. And that's it for the xform graph. So now that we're done with the 4 subgraphs, we're ready for the master graph. The master graph works like this. We have base textures, which are passed into the base color node. Then it's passed into the density node. Then it is passed into the material blend node. The second part of the material blend mode is the decal textures, which are passed into the alpha or mask node, and then the base color node and the xform node. Then this is passed through a series of material blends and also a series of decal textures, and the final result of which is passed into the output nodes, which include a diffuse, normal, and specular. So let's get started. So I have already saved out my previous LD subgraphs, and we'll go ahead and create a new substance, and we'll call this the layered decal. Size mode is also relative to parent, and hit OK. We're going to need 3 base textures. So add a node, color image input. Now, this one's going to be the diffuse, so let's call this the base underscore diffuse. Then with the label, we call it diffuse, and the group is the base. Then we add an item here. The first one is diffuse, so we'll just leave it as is. I'm going to copy this and paste. Then this is going to be our normal, so base underscore normal. The label is also normal, and we'll leave the group as base, but we'll change this as normal. Again, copy and paste, double click. Now this is going to be our base specular, for the label, and usage is also specular. There we go. Now, let's go ahead and select all of these, right click on it, and let's add a frame. Double click on this frame, and we'll call this the base. And I'll just go ahead and drag it out so we have more room here. So, with the subgraphs, we'll go ahead and take a base color from the subgraph, and we'll need a density as well. And right now I am in the compact mode, so I'm going to go ahead and press 1. This will expand the input and the output. So now it's just a matter of connecting things. Diffuse, normal, and specular. And from the base color to the density, like so. Next, we're going to need a material blend mode, and we'll find that in the library. Here it is. And right now it looks really large, so double click on it and we'll turn off some channels. So far everything's set to true, but we don't need ambient occlusion, we don't need height, metallic, roughness, glossiness, and we also don't need a base color, so we only need a diffuse, normal, and specular. Now there are 2 input sets. There's the top here and the bottom here. The bottom here are the base input set. So I'm going to take this and put it into the base, like so. Then we're going to need the decal textures. So I'm going to copy and paste these sets here. Then I'm going to add a new one. Color image input. And this is going to be decal1 underscore mask. The label is mask, and the group is decal1. Usage is also mask. We're going to do the same for the diffuse here. Decal1 diffuse. The group is decal1. Same thing for normal. And same thing for specular. Decal1 underscore specular. And decal1 group. And just to double check that, mask decal1 underscore mask. Now we're going to go ahead and do the same thing by adding a frame here, and this time this one is called decal1. Then taking our alpha or mask node that we made earlier, drag it in. And the way that this works is the second input is the alpha channel and the first input is our custom mask. So we have a custom mask here and that should go into the top here. And then we have a diffuse which may or may not have an alpha channel, and we're going to go ahead and pipe that to the second input here. Then we have a base color here, and we also have a X form here. So again, connect everything up, diffuse to diffuse, normal to normal, and specular to specular. But this time we have a mask, so go ahead and also pipe that into the mask. And the same thing here. Connect. And there we go. Now the result of this X form, we go ahead and put it into the input channels 1. Then this mask is taken and put into the material blend here. Now, depending on how many decals you want, you can copy and paste this setup over here however many times you want. But for now, we're only going to do it twice. So take these, copy, and paste. Let me move that back there. Decal 1 is now called decal 2, and I'm going to make sure that all these input textures have the right group. So it's going to be decal 2, and I'm going to copy paste this group. There we go. Make sure, okay. Copy and paste. Decal 1. I don't think I have put a space here, so I'm going to go ahead and correct that. Decal 1. I like to keep all the names consistent. And decal 1. There we go. Now that we have decal 2 set up, let's go ahead and connect the output of this into the base. Then we take the result and we pipe it into diffuse, normal, and specular. And when I press 3, everything turns into compact mode. So now we have a nice compact graph. However, this is not very useful to us if we don't add any controls. So let's start to expose some input parameters. Now going one by one, I'm going to go ahead and expose this density here. So under instance parameters, go ahead and click on this icon here, and we're going to hit expose. Here in this drop down, go to density and hit OK. Then you'll notice that if we click on a blank space here, that we have a density float, and we'll group this as base. Our default is 1 and the minimum is also 1. Clamp is true, so that controls the density of our base textures. Next, we can expose parameters for the material blend. So here we want to expose the opacity, so expose. And under this pull down, there's a diffuse underscore opacity, hit OK. And we want to do the same thing for normal. So expose. And here's a normal underscore opacity, hit OK. And here, specular, same thing. Expose and pull down specular opacity, hit OK. Now double click on the blank space, and we'll go ahead and set up the labels and the groups correctly. So I want to call this, instead of opacity, I want to call this diffuse strength. And the group will be decal 1. Same thing here, I want to call this normal strength, and it's also decal 1. And same thing for the specular. Make sure to clamp. Next, we want to expose this X form. So again, double click on it. And we pretty much want to expose all of these instance parameters here. So again, expose, scale, hit OK. Expose, rotate is also OK. And we also want to expose this clockwise and counterclockwise. This is the translate, so hit OK. Double click again on a blank space, and we have a bunch of X forms here. Now these all have to do with the decal 1, so I'm going to label them appropriately. Decal 1. And everything is already set up for me correctly because we have it set up correctly in the subgraph. So it's really just a matter of me changing the group name. And that's it. We have our input parameter set up for the base and also the decal 1 textures. Now we can do the same thing for decal 2. Now skipping ahead, your layer decal should look something like this. You have a base density here and a decal 1 set, and then a decal 2 set here. The ordering of these do matter, so let's go ahead and make an ordering that makes sense. We're going to want the translate to be on the top. So let's go ahead and move this translate here under normal strength. Actually, I'm going to put that on the very top, below base density. Then I'm going to take the base and put it on the very bottom here. And what makes sense to me after translate is rotate. And I'm going to put the clockwise or counterclockwise above the rotate here as a checkbox. Then take my scale and put it underneath the rotate. Same thing for decal 2. I'm going to find the translate and put it underneath here. It's the very top of the decal 2. And then I'm going to take the rotate, put it underneath of that. Let's see. And then clockwise above the rotate here. And then the scale underneath the rotate. There you go. And that looks about right. So we have decal 1. And then decal 2 here, and then the base. The ordering of the input parameter is really just up to you, whatever you think is the most friendly to use. Now go ahead and save this package out. Right click, save as, and layer decal is correct. And it has a layer decal graph. Now let's see this graph in action in iClone. Here I have the final layer decal SBS, and I'm going to go ahead and publish this by right clicking on this and hit publish. Then in the directory that you want, go ahead and publish this out as a SBSAR and save. Output size, make sure that is checked. Pixel size and random seed, go ahead and check that and hit OK. Now in iClone, I'm going to take a 3D block wall here, and under materials, I'm going to look for the SBSAR, and here it is, the multi-material SBSAR. I'm going to switch that out for the layer decal SBSAR. So let's start to customize this SBSAR. Under the base maps, I'm going to go ahead and load something I have prepared already, which is the brick wall. Diffuse, normal, and specular. Then I'm going to take out these diffuse here and I'm gonna set it to none. This as well. This is for the decal one. Minimize that. Same thing. Set all these to none. And set. Finally our brick texture is coming out. Now I can change the density by putting a number here. I'm going to go ahead and close this content here so we have more room to work with. For decal 1, I'll go ahead and load in a diffuse. I guess I'll do a window here. You'll notice that it's not that ideal right now because we haven't messed with the scale. I'm going to go ahead and make it smaller and translate that in vertical and horizontal. So I can place it somewhere around there. Then with the other maps, I can use a normal for the window, a specular, and then finally I use a mask to go ahead and get rid of that outline there. Then for my decal 2, maybe I want to do a graffiti here, so this icon here, and again I'm going to size this down, and I'm gonna position this correctly somewhere. There it goes. Okay. Then I'm going to mess with my diffuse strength here. That looks about right. Normal, I'm just going to leave the normal blank actually. And everything else being equal, I'll go ahead and take this normal strength all the way down so that the brick textures show up underneath. Then I'm going to take the specular strength and put it somewhere around 35. So some of that specular from the bricks comes in the forefront here. Next, for the decal 3, I'm going to grab something else. Maybe this door here. Again, we have to scale it. Okay. Also the vertical. And position it. Oh, I think the vertical's way too. I can give it. Oops. Let's see. I think this is going to be a 0.25. Nope, maybe a 0.2. Okay. And then 0.2. No, we want something larger, maybe a 0.25, and then we're gonna position this. That door is really big, so once again, I'm gonna change this around here for maybe a 0.35, and again, position this. There we go. Now it's looking kind of flat because it's using a base normal color, that light blue that we made before in the subgraph. So we want to load the door's normal texture, and we want to load its specular as well. Finally, we want to load the mask, but since we don't have a mask, I think it's okay here. It's looking a little pixelated, and that's why when we did the output, we also have the output size checked, and that allows us to change the output size here in iClone. So right now the output size is 512 by 512, and I'm going to change this to 1024, and we have a much higher resolution result here. So once again, these all work in layers. The base map is the base layer here, so everything else is a layer on top of another. And that concludes our iClone and Substance tutorial. Hopefully that gave you some ideas on creating your own substance materials for iClone.